Hello, this is Mr. Rasmussen with Algebra 2, Lesson 89. Two parts to this lesson. First of all is graphing conjunctions and disjunctions. And then the second part is working through chords and secants to be able to find an answer. All right, let's look at the first part here. A conjunction is where you have two inequalities and there's a word "and" connecting them, or you just have two inequality signs with the x in the middle, and basically both of those have to be true for it to go on the graph and be a valid solution. So that's why it's conjunction, both of them have to work. So our first step in these is actually to get x by itself. So we're going to solve for that. So in this first one here, I'm going to add 3 to cancel it out there, which gives me a positive 1 here. And I'm going to divide by a negative 1 to get the 1 away. So I'm going to get x. Remember, this sign has to flip. When I divide by a negative, this sign, the less than, has to be flipped to a greater than. So over here, 1 divided by a negative 1. So it looks like I have x is anything larger or equal to negative 1. Over here, a little simpler. All I got to do is add 2 to both sides, and I get x is less than 3. All right, so once again, both these have to be true to go onto my graph. Let's work with the x is anything larger than. So it's equal to negative 1. So let's put a negative 1 there and do a closed circle. X is anything larger or equal to negative 1. So I got that graphed first. My domain is just integers, so I'm not going to have a solid line. I'm going to have the circles. So it looks like x is going to go this way until it reaches when? Well, until it reaches 3. It doesn't have a line here, so it's not equal to 3. So the next closest integer that it is equal to is positive 2. So then I'll fill that in there. So we got a 0, 1, and 2, and that is the graph there. It's limited by both of those. Okay, let's look at the second example. This one is also a conjunction. My x in between my two inequality signs is not by itself, so we're going to add a 2 to be able to cancel that out to get x by itself. Now I've got 3 different spots in here. So if I add a 2 here in this middle part, I also have to add it on the outside and this outside as well. So that gives me 0, 0, x is anything larger than 0, but less than or equal to 6. My domain is reals, so it means I'm going to have a solid line. I'm going to start on my left side here with what it's smaller. So here's my line for 0. It's not equal to 0, so there's an open circle. My largest part over here that it is equal to is 6, so a closed in circle to show that that is part of it, and then a solid line connecting the two of those. All right, that is my conjunctions. My disjunction are recognized by this word or. It doesn't mean they both have to apply, just one of them has to apply to get it onto the graph. So once again, let's get x by itself. This one, I got to multiply by a negative 1, which flips my sign. So x is anything less than or equal to 3. Over here, same thing. X is anything greater than, looks like 1. Negative 1 divided by negative 1. Oh, this one's a negative 3. There we go. Okay, so as I graph that, we are going to have x is anything less than or equal to negative 3. Let's put negative 3 up here. It's equal to it, so the solid circle. My domain is all real, so solid line. X is anything less, so I get a solid line going this way with an arrow. X is also anything greater than 1, so I'm going to put my 1 right here. I'll put 0 there. Put 1 right here. It's not equal to it, so it's an open circle. X is anything larger, so it goes this way with a solid line there, but not including 1. All right, and that's how the disjunction works. Let's do example number 4, and then we'll move on. All right, let me get x by itself, so add 2 to both sides. I get negative x is greater than or equal to 2. divide by a negative 1. Remember, my sign's got to flip. X is anything less than or equal to negative 2. Over here, subtract 3 to get away. X is anything larger than 3. All right, let's work with this one first. Put my negative 2 up there. It's equal to it. My domain is integer, so I don't have any solid lines. I just have circles. X is anything less than, so we'll go negative 3 with a dot. Over here, negative 4 with a dot and an arrow showing that it goes in that direction. Over here, X is anything larger than 3. It doesn't include 3, so what's the next largest one? Well, that would be 4, so close circle on 4, close circle on 5, and I'm going to keep going in that direction. Okay, so that is our disjunctions and our conjunctions. The second part of the lesson has to do with our chords. Our chords, remember, is what crosses on the inside. These are all chords here. So you can't see it goes on the outside, I believe. All right, so I have a relation here. In this case, where they cross on the inside, if we multiply the two parts of it, they're going to equal the same number as multiplying the other two parts. So if I take 3 times 4, which is 12, that's the same as 2 times 6, which is also 12. So I can actually solve for an unknown like this by writing 3 times 7, right, this line is equal to 5 times whatever x is. You see how we set that up? Okay, so 3 times 7 is 21 equals 5 times x, divide by 5, divide by 5. It actually comes out, in this case, to a fraction. My answer is 21 over 5 to solve that there. Okay, what happens when they cross on the outside? This one's pretty straightforward. This one's a little tricky. Yeah, you're same multiplying, but you're going to multiply the value that you want to find by the total length of the line. So let's say we want to find one of these two outer parts here. We would do 3 times the total length with this 3 plus 5. So we do 3 times 8 equals, and then 2 times the total length, which is 12. And that works out to be correct. 24 equals 24. So if we take that over here, we're trying to find on the inside part here. So we're trying to find what that part is. Let's set it up the same way here. We're going to do this outside part. 3 times the total length of 8 is the same as 4 times the total length. Well, we don't know what this is, but how would we get the total length? We would write 4 plus x to get our total length there. So that's how we'd set up that equation. And then we'd simplify it, remove our parentheses. 4 times 4 is 16, plus 4x equals 24. Then subtract 16 from both sides. Looks like we get 8 equals 4x, divide by 4, divide by 4, x is equal to 2. Does that work? Well, let's see. If we put 2 plus 4 is 6 as a total length, 6 times 4, 24, yes it does. Okay, they also give you one like this where both the lines don't go through the circle. The one is actually a tangent. How would you find this one? Well, this one here, the 8 is on the outside, but it's also the length of the total line. So it's really the outside and the total line are the same thing. You get 8 times 8, and on the inside would be set up the same way, 4 times 4 plus x, and we'd find that out there. Okay, I'm not going to go through and solve that because just once you can get it set up, then you can find out what it is. Okay, let's move on to our practice problems here. Chance for you to figure out whether you've got this or not. All right, let's look at the first practice problem, and it is set up like this. It has an end in there, so it's a conjunction. Let's get x by itself. I'm going to add 4 to both sides, so I get negative x is less than or equal to 3. I'll divide by a negative 1 on both sides, So x, flip that, is equal to negative 3. All right, over here, I'm going to add a 1 to both sides, so x is anything less than 2. All right, once again, these have to work together. So let's start with what x is greater than. So let's put a negative 3 here. It's got a line there, it's equal to it, so a solid circle. This is integers, so it's only whole numbers. X is anything larger than negative 3. So I'm going this direction. Where does it stop? Well, it's less than 2, but it doesn't equal 2. So it's the next number is less than or equal to 1. So I'd have negative 2 included, negative 1 included, and 0 included. And there is my answer for practice problem A. All right, practice problem B, once again, is a conjunction. See the way it's set up there. I'm going to get x in the middle of my two inequalities by itself, so I'm going to add a plus 1 to all three spots. Looks like I get 0. X is anything larger than 0, but less than or equal to 4. So I'll put 0 on here. My domain is reals. It doesn't include the 0, so I have an open circle. It goes all the way to a 4, which it does include, so closed circle. And since it's reals, I got a solid bar line there as my answer for B. All right, for C, it's all on the inside of the circle there. So I get 3 times 4 is equal to x times 7. 3 times 4 is 12. Divide both sides by 7. My answer for x is 12/7. Okay, here, once again, a little differently because we got to add them up. My first line, the outside is 6 times the total length of the line, which is also 6. Here, my outside times the total length, which I don't know, is going to be 4 plus y to solve that. So I remove my parentheses, I get 6 plus 4y is equal to 36. Subtract 16 from both sides. Looks like 20 is equal to 4y. Divide by 4, divide by 4. And looks like y is equal to 5 for my answer there for practice D. Okay, if you have any questions, please feel free to contact me. Have a great day.